Hi there, this is Penelope. This is the second video in the couple of videos on solving complex equations, and remember, finding roots is what we mean by solving complex equations. First one's moderately easy, just find the roots or solve. So we'd use the quadratic formula, which would say that z equals -3 plus or minus the square root of 3 squared minus 4 times a, which is 2 times c, all over 2 times 2, and that works out to being -3 plus or minus the square root of -23 over 4. Now we can deal with the root of -23 now, because it's a j thing. And now we would just break it up to say that z is equal to -3 over 4 plus or minus j root 23 over 4. Further, we could say actually -3 plus j root 23 over 4, or -3 over 4 minus j 23 over 4. It just depends how you're asked to write the answer. The next one kind of looks easier, but it's maybe takes a little bit more thinking. What we can do, and possibly this is your first thought, is you could rearrange it so you've got that. Now if we were drawing that, that's -2, that's just there. We know what z is. We know that z is r angle theta, which means that we know then that z to the power of 4 is going to be r to the power of 4 angle 4 theta. Now, if we were going to write this out as a complex number, it would have been equal to -2 plus 0j. So that's what we've got there. And in order to write that in polar form, we would have written that that was actually 2, because its length is 2, angle pi, and then because we can go on lots of times, it would be pi plus 2k pi, where k is 0, 1, 2, and 3. So we've got z4 as being equal to that, but we actually know that z4 is something else. So we can make these two things equal. So z to the 4 equals r4 angle 4 theta, which we now see is 2 angle pi plus 2k pi, where k is equal to 0, 1, 2, or 3. Okay, so now we can equate the bits that are the same. The r4 must be equal to 2, so r to the power of 4 is equal to 2. So r is equal to 2 to the quarter, and equal comparison, so 4 theta must be equal to this bit. So 4 theta must be equal to pi plus 2 pi k, which gives us that theta is equal to that divided by 4, all right, we're done. We can put that together and now say that z is equal to 2 to the power of a quarter angle pi by 4. That's when k is 0, or 2 to the power of a quarter angle pi by 4 plus when k is 1, so that would be pi by 2, or 2 to the power of a quarter angle pi by 4 plus 2, so k is 2, so it would be 2 pi over 4, so it would be 4 pi over 4, so it would be pi, and then the fourth one would be plus 3 pi over 4. I mean 3 pi over 2, not 4, 6 pi over 4. Okay, if you were to draw it, I've run out of space, but if you were to draw it, it's got 4 roots. So the first one would be there, that angle would be pi by 4, and that length would be 2 to the power of a quarter. There's another root, another root, another root, because they're all all 90 degrees apart. This question we do similarly. We know what z is. Z is equal to r angle theta. So z squared equals r squared angle 2 theta. But this r squared angle 2 theta is equal to 3 plus j, which in polar form is 10 to the half angle 0.322 plus 2 pi k, where k is equal to 0 and 1, right? So since there are 2 roots. That means, again, we can compare the bits. So we can say that r squared must be 10 to the half. Oh, actually, no. What I need to do first is go back and find 2 theta. So if 2 theta is that, then theta is going to be 0.32, or 175 maybe, divided by 2 plus 2 pi k over 2, where k is equal to 0 or 1. Okay, so that was just finding theta. R squared must equal 10 to the half. Again, I'll finish what I was doing with my fancy colour there. So that is 10 to the power of a half. So R is 10 to the power of a quarter. Putting it all together then, the solutions are that Z is equal to 10 to the power of a quarter angle, now that first one is 0.32 divided by 2, so that's 0.16, where k is 0, or z equals 10 to the power of a quarter, and it'll be that number plus 2 pi times 1, that's 2 pi over 2, which is pi. And if you were asked to draw that, there would be the first root, 0.16 in there, and that would be the length 10 to the power of a quarter. And then the second root, because they're 180 degrees apart, would be down here. So there's at the same length. So there are the 2 roots of z squared equals 3 plus j.